Hello. Today's class is going to be covering Unit 3, which is going to be the financial unit. So today we're going to start with simple interest. So we're just going to cover simple interest in this class today. So today we're going to, like I said, start with simple interest. So some of the vocabulary we'll be going over today is interest, simple interest, principal, and rate of interest. So those are all things we're going to learn about. So interest, I'm sure you've heard of interest before. Interest is the amount of money that's charged for borrowing or using money. When you deposit money into a savings account, you are paid interest. So sometimes you can be paid interest depending on what kind of savings account you have, or, for example, like a TFSA sometimes has a portfolio that you can invest to save interest, but for the most part, most of us are used to paying interest on something we've taken out. So a loan or something like that. So anytime we've borrowed money. Simple interest is one type of fee paid for the use of money. So simple interest is a specific type of interest paid. So there's a couple different ways that you can collect interest or gain interest or be charged interest. And today we're just going to cover simple interest. So the formula that we're going to use mostly today is I equals PRT. And I in this equation is the simple interest. So it's the money paid on the principal or the money gained on the principal. So this is just the interest. In this case, simple interest. P is the principal, and that's the amount of money we've borrowed or we've invested. But usually in these questions, we're going to look at the amount of money borrowed. So that's without any interest. So let's say it was a car loan or something. The principal is the amount of money that's been borrowed. Rate, so R in this equation is known as the rate of interest, and it's the percent charged or earned. So rate is always given in a percent, but when we're using it to calculate in these formulas, we have to convert it to a decimal. So we're just going to simply divide by 100 in each of those questions. So rate always has to be in decimal form, not in percentage. And T is the amount of time in years that the money is borrowed or invested. So the biggest thing here is that it has to be in years. So if we're given weeks or we're given months or we're given days, we have to make sure that we're converting our time into years. So we'll start with P plus I equals A. And let's backtrack. I equals PRT. So we just talked about this formula. So this is the interest and the principal and the rate and the time. And in this equation, we can actually rearrange this a few ways. So we can use this equation to solve for our principal if we know our interest, our rate, and our time. We can also use it to solve for rate if we know interest, principal, and time. And we can also use it to solve for time if we know I and P and R. So P plus I is equal to A is another formula. And this one is really just, and we'll talk about it a couple times in this PowerPoint, is a way that you can calculate the amount. So, amount is the principal, so the money that we've borrowed or invested, plus the amount of interest earned. So when we add those two together, we get the amount. So this is maybe the total amount that you owe by the end of the term, or it could be the amount that you get at the end of the term, so investment-wise. So to first example, so example 1, we're going to find the interest and the total payment of a loan. So to buy a car, Jessica borrowed $15,000 for 3 years at an annual simple interest rate of 9%. How much interest will she pay if she pays the entire loan off at the end of the 3rd year? What is the total amount that she will repay? So we know that she's borrowed $15,000. We know that, so maybe let's write that down. So I do have most of this written out, but we know that she borrowed $15,000. So that's our principal because that's how much we've borrowed. She's done it for 3 years, so that's our time. It's already in years, so we don't have to worry about that. And we also know that our rate is 9%, but we always want to make sure that's in a decimal. So let's divide that by 100, and that gives us a rate of 0.09. And they want us to find how much interest she will pay and then what is the total amount that she will repay? So we're also going to find amount. So we have two things to do. We need to find our interest first, calculate amount. So we're going to first find the interest she will pay. So I equals PRT is the formula we're going to use. So these little dots indicate multiplication, but usually it's just written like I equals PRT. So all of these touching indicate multiplication. So we talked about that 15,000 was my principal, so I put that in for P. My rate, I converted to a decimal. It was given as 9%, but we divided by 100, which gave me 0.09. And our time was already in years, so we used just 3. And we're just going to plug those into our calculator, and we get 4,050. So our interest paid on that loan for 3 years at 9% would be $4,050. Doesn't seem like you should be paying that much, but you are. So now, just because we didn't have room on that slide, we're going to figure out the amount that she has to repay as well. So we know to find our amount, we have to take our principal plus our interest. So we just calculated our interest in the last question, which was 4,050. And we also know that the original principal amount that she borrowed was $15,000. So when we add those together, we find that the total amount that was repaid on this loan was $19,050. So she would repay a total of $19,050 on her loan. Okay, example 2. To buy a laptop computer, Elaine borrowed $2,000. So this is how much she's borrowed. We know that's her principal for 3 years. So again, our T is equal to 3. At an annual simple interest rate of 5%. So R is equal to 5%, but we always want that as a decimal, so we're going to get 0.05 as our rate. How much interest will she pay if she pays the entire loan off at the end of the 3rd year? What is the total amount she will repay? So again, we're trying to find our interest and our amount. So the exact same as the last question. So let's first find the interest she will pay, because we can't find the amount because we only know the principal, and we know the formula to find amount is principal plus interest. So we need to calculate how much interest she's paid. So let's start with I equals PRT. That's our formula for simple interest. The principal was 2,000. The rate we converted to a decimal was 0.05, and our time was 3 years. So we're just going to plug that into our calculator, and we find an interest of $300. So the second part, we know that she paid $300 in interest, and we also know that her original amount, so first P plus I equals A, that's how we find our amount. We've calculated interest as $300. We know that the original principal value that she took out was $2,000. So the total amount to be repaid on the loan was $2,300. Okay. So a different example. So in those last ones we were calculating interest. In this case, we're calculating the amount of investment time. So we're finding time instead of interest. So we know that she invested $6,000. So in this case, she didn't borrow, she invested, but that's still our principal amount in a bond at a yearly rate of 3%. So she makes 3% yearly on this bond. So we know that our rate is going to be 0.03. She earned $450 in interest. So we know that she earned $450 in interest. How long was the money invested? So how long did she actually invest it? So we know she makes this amount yearly, but how long was the money sitting in that account for? So we're going to start with the same formula. In this solution, I have it set up that we calculate for T later, but remember on that first formula sheet, and I will email the formula sheet out, or maybe I'll even post it on the Blackboard page for those of you who aren't in this class. The formula that we also were given is that T is equal to I over P times R. So that's just rearranging this formula to isolate T. So T is equal to I over PR. So you could just straight up use this formula and plug everything in, or you could do it the way we're about to do it. I'm just going to erase that because stuff's going to pop up over here. And solve or isolate T at the very end using algebra. So we know our interest or amount is $450, our interest amount. Our principal that we've invested is $6,000 at a rate of 3%, which again, we've converted to a decimal. So we're going to solve for time. So what they've done here, or what I've done here, is 6,000 times 0.03. That gives me 180. So I've just combined these. And then to get t by itself, I have to divide this side by 450, or sorry, oops, that is not what I meant to say. It should be by 180, my apologies. Okay. By 180 and the other side by 180. And that gives us a total of, 2.5 as our T. So this means that the money has been sitting in that account for 2.5 years to be able to have gained $450 in interest. So let's say we did want to use the formula that I've provided, and probably the formula that you will have on your formula page. So the formula is T is equal to I over P times R. So we know our I is 450. We know our P is 6,000 and our R is 0.03. So if you're going to plug this into a calculator, make sure that you use brackets on the bottom to tell the calculator to do this first, or you could do it in parts. But when you plug this all in, you will still get the answer of 2.5 years. So remember, time is always in years. So the money was invested for 2.5 years or 2 years and 6 months. But 2.5 years is fine to say. TJ invested $4,000 in a bond at a yearly rate of 2%. He earned $200 interest. How long was the money invested? So again, we have our formula I equals P times R times T. We're going to sub in. This is the money that was invested. That's our principal. This is the interest earned. That's our I. This is our rate of 2%, but we're going to divide by 100, so we get 0.02. Again, you could have used the formula I over PR here and calculated the same way, but here we're going to do 4,000 times 0.02 gives me 80, and then my last step is to divide both sides by 80, and we get T is equal to 2.5 years again. So the money was invested for 2.5 years or 2 years and 6 months. You won't always get the answer of 2.5. It just worked out that way, but the biggest thing here is knowing to isolate for T or using the formula that's provided. So now let's figure out example 3 is computing total savings. So John's parent deposited $1,000 into savings account as a college fund when he was born. How much money will John have in his account after 18 years at a yearly simple interest rate of 3.25%? So, oh, actually, I'm not going to write it out because it's going to be popping up here. So I equals PRT. In this case, we are being asked to, we're being asked to find how much interest is earned in 18 years, right? But they want to know how much he will have in his account. So that's kind of the tricky thing here is how much will he have in his account? So he's not just going to have the interest amount in his account. It's going to be the amount, right? So it's going to be whatever was originally deposited plus the interest earned. So how much will John have in his account after 18 years at a yearly simple rate of 3.25%? So our principal was $1,000. It's given in the question. Our rate was 3.25. When you divide this by 100, you get 0.0325. And our T is 18 years. So we're going to substitute that 0.3, all those numbers in, plug it into our calculator, and the interest earned on that amount of money at that interest rate over 18 years is $585. Doesn't seem like a lot, but it's only $1,000. That's not only, but it's $1,000 that's been invested over 18 years. So could you imagine if they invested $1,000 every year? So that actually is what we call compound interest. So that's when you have an interest amount compounding over a certain amount of time. We also have future value, which allows us to say, like, you know, for some people they invest multiple times a year or once a month, depending, and that's called future value, which we might get to in this unit, but for sure we'll get to compound interest. Which is a little bit different. It compounds over time. It doesn't compound like annually like simple interest does, where simple interest is just done annually, and then we can leave it in for however many years we want or borrow for however many years they let us. So that's our interest, but are we done No, we still have to find the total. So to find the total, we have to use P plus I equals A, because we know that the original amount of money that was invested was 1,000 and the interest earned was 585. So we add those together. So John will have $1,585 sitting in that account after 18 years. So this is the biggest thing that you need to watch for. If we go back to this question, it says, how much will John have in his account after 18 years? It doesn't say how much interest will he earn, right? So that's a big part of the word problems is identifying what you're being asked to solve. Bertha deposited $1,000 into a retirement account when she was 18. How much will Bertha have in the account after 50 years at a yearly simple interest rate of 7.5%? So the 18 is there to kind of throw you off. She started when she was 18, but she has it in an account 50 years. So it sits there for 50 years and it collects a pretty high interest rate of 7.5%. So we're going to first use the formula I equals PRT. So remember, it says how much will she have in the account? So are we asking for interest? No, we're asking for the amount, right? But we need to calculate interest first. So our principal amount that she invested was $1,000. The rate was 7.5%. We divide that by 100, so we get 0.075. And the amount of time it was in the account was 50 years. So she put it in when she was 18, but it sat there for 50 years. So the 18 actually has nothing to do with it in this question. It's just kind of there to, not necessarily trick you, but just give you more information. So when we calculate that, we find that Bertha would have made $3,750. So let's find the total. We know that she originally invested, or her principal amount that was put in was $1,000. The interest over the 50-year period was $3,750. So in 50 years, just that $1,000 sitting in that account would make her $4,750. Now, because we don't have a lot of time, we don't really talk so much about the importance of investing in this unit, but if this is something that you're interested in, you can certainly talk to your teachers, or there's a lot of information on investing all over the internet. But the biggest thing to know about investing is time is your best friend. So maybe you can't invest a lot of money over a long period of time, but in some of these, depending what kind of investing you're doing, you can gain money just having it sitting there, right? So she just had this $1,000 sitting there and she made an extra $3,750. And that's because she left it in there for a large amount of time. So compound interest and interest are like your best friend. And the biggest thing about it is the amount of time. So the earlier you can invest, the higher chance you have of making money, is basically, I mean, the very, very minimal amount of information on investing. But so after 50 years, she's not even at $1,000 anymore. She's at $4,750, which is pretty cool. So now, what if we're asked to find the rate? So we've calculated finding the time, we've found the interest, we found the amount, but now what if I find rate? So we start off with, okay, sorry, back up a minute here. So Mr. Johnson borrowed $8,000 for 4 years. So this is the principal amount he borrowed for 4 years to make home improvements. If he repaid a total of $10,320, so that's the amount he repaid, right? So we're given amount and we're given principal. At what interest rate did he borrow the money? Here's the thing, we're kind of working backwards in this case. We actually don't, in order to find rate, right, we have I equals PRT. So in order to find rate, I need to have my interest, my principal, and my time. So if you remember, or if you flip back or look at your formula sheet, rate is equal to interest over principal times time. So I need to have these three things. The problem is I know my principal and my amount, but I don't know my interest. So let's figure that out. So I know that my principal is 8,000, my amount is this. So my interest is actually just going to be 10,000. So remember algebra, if I bring this over to this side, I have to subtract it. But really, you don't even have to do this formula. You can make sense of the fact that this is the amount that I borrowed. This is how much I paid back. So if I subtract these two, I'll get how much money, how much interest I paid. So that's $2,320. So that's how much interest he used. So this is going to be our I. So we had to calculate it, but now we have I, we have P, and we have T, which is 4 years. So now we can go ahead and calculate our rate using this formula. So again, in these slides, I'm using I'm not actually isolating R like I did in that previous slide for the formula, but you can do it that way as well. I'm just plugging in my interest that I calculated. So 8,000 times 4 is going to give me 32,000. Divide both sides by 32,000. And you're going to end up with 0.0725. That's our rate as a decimal. And if you multiply that by 100, that will give you, so if you take that and multiply by 100, that will give you the 7.25%, or 7 1/4, but 7.25 is perfectly fine. That's how much, that is the rate at which he borrowed the money. So that was the annual rate he was given, or charged in this case. So Mr. Mogi borrowed $9,000 for 10 years. So that's the principal. This is our time to make home improvements. If he repaid a total of 20,000, so again, that's the amount he repaid. What is the interest rate? So same thing here. What is the rate? So we're going to do the same thing. We're going to use our principal and our amount to calculate our interest. So I'm just taking 20,000, subtract 9,000, that gives me 11,000. So that is how much interest this Mr. Mogi paid. Now we can use that amount that we've calculated in our formula to calculate for our rate. So if you wanted to use the formula, which is it's the exact same thing they're doing here, it's just kind of laid out for you. My interest is 11,000. My principal is 9,000 times my time, which is 10. And then when I calculate that, I will end up with the exact same answer. So here we've combined 9,000 times 10, that gives me 90,000, divide both sides. In both cases, we end up with 0.12, which is multiplied by 100. If you multiply this by 100, you get 12.2%. So you would have got the same thing with this here. So if you also did it using this formula, you would have found the same answer. Just when you're typing this in your calculator, make sure you use brackets on the bottom, or you could just do the math on the bottom, which gives you 90,000, and then put that into your calculator, which is exactly what happens here as well, and you would have ended up with 12.2%. So let's look at this one. If we have 2,000, it's invested today. So $2,000 is invested, so that's our principal. At a term deposited at 6% interest, so let's convert that to a decimal right away. That's our rate. What amount would be paid back at the end of 11 months? So we want to find amount. And here, if you notice, in all the other questions, we were given years. So in this case, we're given 11 months. So we actually need to convert that to years because time has to be in years. So how many months do I have in a year? 12, right? So if I take my 11 months, divide by 12, that will give me the time in years. So you can keep this as a fraction, most students do, or you can convert this to a decimal. The problem is sometimes we have infinite decimals, and in that case, we end up losing some values, but let's just keep it as 11 over 12 years. So we want amount, but remember, we always have to start by calculating our interest first. So our principal is 2,000. Our rate is 0.06 and our time is 11 over 12. So remember, we can use the fraction button here. So let's maybe pull it up and we'll do it together. Okay, so we had 2,000 times 0.06 times 11 over 12, and that gives me 110. So 110 is the answer there. So that gives me $110 in interest. But it's asking for the amount to pay back. So remember, our amount is principal plus interest. So the amount of principal was 2,000. I don't really need this bracket here, but that's okay. 2,000 plus 110. So the amount that I pay back is $2,110 is the amount that would be paid back at the end of 11 months. Okay, let's maybe look at one with days instead. And then I would like to give a list of all of the conversion factors that you might need to know. I can't remember if it's really given in the book, but sometimes you need to convert from days to years or weeks to years or bi-weekly to years. And we will talk about this more when we get into the compound interest portion. Ken invested $2,500 in a 90-day 3.25% term deposit. How much will he receive at the end of 90 days? So first thing we need to figure out is our principal. What is it? It's $2,500. That's how much he originally invested. Our time, the problem is we're given 90 days. So we need to get this into years. So we're going to divide this by 365 because there's 365 days in a year. And then our rate is 3.25. So 3.25 is 3.25%. But remember, we're going to divide that by 100. So we get 0.0325 as our rate. So remember, time has to be in years, rate has to be in decimals, and then we can continue on. So how much did he receive? So again, we're being asked to find the amount. But in order to do that, we're going to calculate our interest first. So our interest is P times R times T. My principal is 2,500. My rate is 90 over 365. And my time is 90 over 365. My rate is 0.0325. And my time is 90 over 365. So let's do that in my calculator. So we have 25, so 2500 times 0.0325 times 90 over 365. So I'm getting $20.03. That seemed low to me, but he's only putting it in for 90 days, so that's actually probably correct. So we have $20.03. But the amount, remember, is our principal plus our interest. So we had a principal of $2,500, and the interest we just found was $20.03. So we have a total of $2,520.03 is the amount that Ken will receive at the end of 90 days. So everybody's looking at me right now, and because I don't have any students in class, nobody called me on this. It was 13.25%. Let's assume it said 3.25 because that's how I calculated it. 3.25. I'm so sorry. So I assumed that it said 3.25. It definitely says 13.25, so it should have been 13.25, which would have given me 0.1325, which would have given me a completely different answer. But let's pretend it said 3.25%, because usually there's students that say, Kyla, it says 13, but there wasn't. So I'm sorry about that. But the process is exactly the same. There just should have been a 1 in front of here and then a 1 down here. Yeah. Okay, so let's maybe erase this. Let's just quickly write down a couple things. So the days in a year, so this is all for conversion, right? So how many days in a year? We have 365. Months, we have 12. Weekly, so there's 12 months in a year, there's 365 days in a year. Weeks in a year is what is it? 52. Oh my gosh, sorry, 52 weeks in a year. So you might have to do that. You might have to do months. And then, bi-weekly is 26. I think that's all you'll need to know. Now, if there's something that you don't see in the booklet, or you see in the booklet that isn't making sense, or in the assignment, just send me an email. But for days, you're going to divide by 365. For months, you divide by 12. Weeks, you divide by 52. And bi-weekly, I don't think you'll need to use in simple interest, but if you do, it's 26. This will probably be more of a compound interest type question, and we'll talk more about that in the next lecture. So we'll look about semi-annually, annually, and that's compounding periods. So we're going to stop there.